Okay, here we go. Pre-calculus, chapter 12, section 5, homework page 860. Okay, the area problem. Area under the curve. So in this lesson, we want to find limits of summations and find areas of plane regions. Okay, so just a couple quick things about summation notation. The sum of I equals 1 through n of c, which is just a constant, is just going to be c times n. Okay, so easy formula. The summation of I equals 1 through n of I is going to be n times n plus 1 over 2. The summation of I equals 1 through n of I squared is n plus 1, 2n plus 1 over 6. And then cube, I cubed is n squared, n plus 1 squared over 4. Then we'll talk about areas under the curve above the x-axis. Okay, so area under the curve using antiderivative. Ooh, this is a new one we haven't talked about. This is called the antiderivative. So when you see a capital letter, capital F, that refers to the antiderivative. So this little squiggly here, okay, means antiderivative. So to take the antiderivative, you are going to go backwards, okay, from taking a derivative. So when you have x to the n, the antiderivative is you're going to boost the power up by 1, and you're going to divide basically by that new power, or 1 over that new power, okay? And then the new power will be x to the n plus 1. And then you have to have a plus c, because this covers any issues that you may have. Okay, so we'll do some examples on that. And then so the area under the curve from the integral from a to b of a function is just take the antiderivative, evaluate at b, minus the antiderivative, evaluate a. So that's what we're going to try to do today. Okay, so let's do some problems. Okay, so let's say, for example, evaluating some sigmas, okay? For example, I equals 1 through 50 of I squared, okay? So what does this mean? This means 1 squared, 2 squared, 3 squared, 4 squared, okay? We want to add all of these up to 49 squared and 50 squared. The reason I'm going to stop at 50 because my index up here says I go from 1 through 50. So how am I going to add all of these? Okay, it's going to take a long time if I do it manually. All right, so I don't want to do it manually. I'm going to use my formula. So my formula is for I squared. For I squared, formula is going to be n plus 1, 2n plus 1 over 6, where n is how many numbers I have all together, okay? How many numbers do I have here? There's 50 of them, right? 1 squared, 2 squared, 3 squared, all the way up to 50 squared. So I'm going to put 50 in for n. So I'm going to get 50, parentheses, 50 plus 1, 2 times 50 plus 1 over 6. So 50, 51, 101 over 6. Okay, so if you do some canceling, right, 6 goes into 50 25 times with a 3 here. 3 goes into 51 17 times. All right, so you end up with 25 times 17 times 101, which if you punch in the calculator is 42,925. Okay, so just using the formula allows you to compute real quick without necessarily doing manually. Okay, so that's how you use that. Let's say, for example, summation of I equals 1 through 17, let's say, of I. Okay, so when we have this, it's going to be 1, 2, 3, 4. And this goes up to 15, 16, 17. If you were to add up all these numbers, what would you get? Of course, you can do it manually, but there's a better way. Okay, so using the formula for I, this can be n plus 1 over 2, really simple, where n is how many numbers you have. Okay, so in this case, n equals 17. So now we're going to put 17 into this formula. 17 plus 1 over 2. So you get 17 times 18 over 2. 17 times 9, right? So we're looking at 170 minus 17, 153. There you go. Okay, so try to use your formula. That's all that is. Okay, one last one then. One last one. So for example, let's say cube. Summation of I equals 1 through 10, okay, of I cubed. So this is real simple, okay, 1 cubed, 2 cubed, 3 cubed, plus dot dot dot, plus 8 cubed, 9 cubed, and 10 cubed. I stopped at 10 because of my index. Okay, so you can do this manually, but might be time consuming, right? So using the formula n squared parentheses n plus 1 squared over 4. That's it. In this case, n equals 10. So we have 10 squared, 10 plus 1 squared over 4. Okay, so we get 100 plus 120, times 121, right, over 4. So 25 times 121, okay? So we just can evaluate this out. Okay, so this will give us, what, 3,025, I believe. Okay, looks like it. There you go. All right, so now let's talk about area under the curve. Area under the curve has a formula here. So area is going to be the integral. So integral, like a long S, from A through B of f of x dx. So think about this as like a derivative already. And so what we need to do is find the antiderivative of b minus the antiderivative of a. Okay, this capital letter means antiderivative. Okay, so when you're looking at a function, you gotta ask yourself, what made that? Okay, so for example, let's say okay, so example, okay, integral from 8 through 10 of x plus 2 dx. Okay, so now if you think about this, let's say if you draw it out, okay, x plus 2, so here's 1, 2. If you draw out this line, x plus 2, okay, and okay, so what they're asking you to do is to draw this out like this, for example, like that. Okay, so from 8 to 10, from x equals 8 through 10, what's the area under this line from 8 through 10? Okay, that's what we were trying to find out. So you have to do what's called the antiderivative. Okay, so if you look at x plus 2, think about go backwards. What function has a derivative of x plus 2? Okay, so the way you do that is x has a power 1 currently, and so you add 1. You take the power it currently has, you add 1, and you divide by that new power. What's this new power going to be? 2, right? Okay, so plus 2. Now 2 actually has an x right there, right? If you think about it carefully, I can easily say this is 2 times x to the 0, right? 2 is the same thing as 2 times x to the 0. So this currently has a power of 0. So I'm going to add 1 to the power. I'm going to divide by that new power. The new power here is 1. Okay, so the antiderivative, okay, basically you take the problem and you go backwards, okay? So it is 1/2 x squared, right? I'm rewriting this, plus 2x, okay, divided by 1. Now, anytime you take the antiderivative, you always have to add c at the end. This is very important, okay? You have to take, put plus c when you take the antiderivative, okay? So here's your function. Antiderivative of your function is 1/2 x squared plus 2x. So now that we have found the antiderivative, we say 1/2 x squared plus 2x plus c. Okay, now you see earlier it was a squiggly. Okay, it's called the integral. That's kind of like reminding you need to take the antiderivative, but I already did that. So once I've done that, they use this notation of a straight line that denotes that, hey, I already took the antiderivative of, so now I'm going to do 8 and 10 here. So what I need to do is plug in 10 and plug in, so f of 10 minus f of 8. Okay, so let's take this number 10 and plug it into here. 1/2 10 squared plus 2 times 10 plus c. All right. And then once I get that answer, I'm going to minus 1/2 8 squared plus 2 times 8 plus c. Okay, so I evaluate this first and then subtract what I get here. Okay, so 1/2 of 10 squared, that's 50, plus, right, 20 plus c. So this is 70 plus c. I can't add these, right? No, not allowed. Not like terms. So I get that. Minus. Okay, let's evaluate this. 1/2 of 64 plus 16 plus c. So half of 64, 32, right? 32 plus 16 plus c. Okay, so 48 plus c. Okay, so when you have this, you're going to get 70 minus 48. So 22 and c minus c. That's it. That's this. This is called the area under the curve. Okay, that represents this space right here. The area under x plus 2 from 8 to 10. From 8 to 10. That's how much space is under this line from 8 to 10. Okay, that's called the area under the curve. Let's do some more examples. Okay, so again, we want to know area from x equals 0 through x equals 2 of the function x squared plus 1, like say, for example. So the way you write this is integral. This is called the integral from 0 through 2 of x squared plus 1 dx. Okay, now we have to find the antiderivative, okay? So might be a little tricky at first, okay, but you gotta try to get used to it. So x squared currently has a 2 right here as a power, plus 1. Now what's the power here for x? Plus 1, x power currently is 0. Okay, so if you notice, this is x squared, this is 1. Currently the power is 2. Currently the power here is 0. So what we're going to do is we're going to add 1, and the new power is 3. We're going to add 1, the new power is 1. Okay, so the antiderivative, which is using a capital letter X, it's going to be 1/3 x cubed plus x, now plus c. Make sure you have that c there, okay? That's called the antiderivative. So now that we have the antiderivative, it's going to be 1/3 x cubed plus x plus c. Now we're evaluating at 0 and 2. Okay, we need to plug in 2 minus what happens when we plug in 0. Okay, so 1/3 2 cubed plus 2 plus c minus 1/3 0 cubed plus 0 plus c. All right, let's evaluate this. Okay, when we evaluate this, we get 1/3 times 8 plus 2 plus c. So this will give us, let's see here, 8/3 plus 6/3 plus c. So 14/3 plus c. Over here with 0 plus 0 plus c. So we just get c. So minus c. 14/3 plus c minus c. So the area under the curve is 14/3. This is called the area under the curve. Okay, there you go. Okay, hopefully you understand that. We'll do some more examples then, okay? All right, let's say, for example, let's see, next one more example, okay? Integral from 4 through 8 of 2x cubed plus 6x dx. Okay, so we want to know what's the area under the curve between 4 and 8 of this function. Okay, so we gotta find the antiderivative. So 2x cubed plus 6x. What's the current power? Current power is 3 and 1. Okay, so now we're going to take this current power of 3. We're going to add 1 to it. The new power now, after we add 1, is going to be 4. Now let's add 1 to this guy. What's my new power going to be here? New power is 2, right? So the antiderivative, if I simplify this, is 1/2 x to the 4th plus 3x squared plus c. Okay, whenever you do antiderivative, you always gotta have a c. So now 1/2 x to the 4th plus 3x squared plus c. Okay, this is the anti. Now we're going to evaluate 4 and 8. So we do f of 8 first, minus f of 4. All right, let's plug in 8 and then plug in 4. So 1/2 8 4th power plus 3 8 squared plus c. Compute that. Minus 1/2 4 to the 4th plus 3 4 squared plus c. Okay. All right. So now your job is to figure what is 1/2 of 8 to the 4th. Well, let's see about that. Okay. 8 to the 4th times 1/2, okay? So we're looking at 2,048 plus, okay, 64 times 3, 192 plus c. Okay, so now we get here 2,240 plus c. Now let's do this guy. Okay, so 4 to the 4th is 256. So 1/2 of that. So 1/2 of 256. That's going to be 128 plus 48 plus C. So we got a minus, right? Here, 176 plus C. So the C values will cancel. So really we have 240 minus 176. So we're looking at let's see, 176 2,064. Alrighty. That's it for that. Okay? try and用。